In today's lesson, we're going to look at the carbon cycle, the global and local stores and flows within the carbon cycle, and we're going to look at why carbon is so important to life on Earth. This is part of 1A in the spec. Those are the two highlighted sections, and so that's what we need to know, why we're learning this. A quick recap. The carbon cycle is like the water cycle, and that at a global scale it is a closed system. Energy can pass through the boundary of the system, but nothing else. That means energy from the sun will kind of affect what's going on in the global carbon system, but we're not going to lose any carbon out into space. Within the carbon system, if I look at it at a kind of more localized level, so if I look at a forest or a peat bog, they are going to have inputs and outputs, and they could lose carbon from that forest or peat bog into another area. And so those, again, a bit like the drainage basin and the water cycle, is an open system. So we have both closed and open systems that we need to consider. We need to have a look and rank the kind of different stores of carbon depending on their importance. So right at the top we have sedimentary rocks, things like chalk and limestone, followed by the oceans, which nearly 40,000 gigatons of carbon. Seafloor sediments are right at the bottom of the ocean. Fossil fuels, that's where we see carbon in the form of oil and coal and gas. Soil, atmosphere, and then land plants last. So the pattern really here interesting to see is that the sedimentary rocks have significantly more, so 60 to 100 million gigatons, 60,000 to 100 million gigatons, where the next one is only 40,000 gigatons, so a significant amount in those kind of limestones and chalks and similar type of carbonate rocks. Also, the oceans is an interesting one because the oceans aren't just one singular system, and the fact is they are split up into almost different layers, and so there's different parts of the ocean store different carbon. So the surface does store carbon, but also the deep ocean is where most of it is going to be stored. So we need to know that when we see that figure for oceans, that can even be split further into different parts of the ocean. The last point I wanted to kind of highlight was just the fact that land plants, so our trees and forests, which we really do associate when we think of carbon, we think of those processes like photosynthesis, but unfortunately they actually don't store that much, and so that's a really significant thing to know because it plays into the carbon cycling aspect of it. Here is another map that shows the kind of flows and stores. So the yellow, green and pink are the stores in the boxes, and the reds are the flows between. We can see that lots of arrows are going into the atmosphere. That's a really key kind of location for still not for storing carbon, but for the actual circulation. So only 600 gigatons there. It sells very little, but it's really key. All those arrows, those processes and flows going into it show that it's a really key area. We also see the residency time, which is in red, which basically means the amount of time that carbon is stored in that area. It's quite low, so 6 years. That again links back to the idea that is rapidly going into the atmosphere and then rapidly coming out through a different flow. I've also circled areas on the oceans here and the sedimentary rocks. Residency time for these is significantly higher. So in the deep ocean, it's nearly 1,250 years. But in sedimentary rocks, it can be millions of years. So key thing to know that where there is more of it being stored, obviously, there's a longer residency time. So in these areas, they are being kept in there for a long time, sometimes thousands of years, millennia. All of this is really important. We're going to come on to the kind of slow carbon cycle and the rapid carbon cycle, but it's important to know that there's differences in the stores, there's difference in the residency times. These are just some pictures to show you it talked about sedimentary rocks. On the left we have limestone pavement here, and on the right we have chalk. So this is just a physical representation of those kind of rocks that we talked about abstractly, and thinking about that is where a lot of the carbon on Earth is actually going to be stored. Similarly, Here's that kind of diagram just to show you that how significant the deep oceans are. We can see these blue squares here. They show you how much of the carbon is stored in that part of the ocean, and it's most of the total value, and it's significantly higher than what we get in the ocean surface. So just looking at the spatial elements there, we talk about oceans being really important carbon store, but it's important to know where that is in the ocean, not so much on the surface. The surface is where it's circled and circulated, but in the ocean is where it's actually stored. The last thing to discuss is the importance of carbon. So we can look at it in terms of plants. Plants have carbon involved in it in a couple of really key processes. So CO2, carbon dioxide, is used with sunlight to make food through the process of photosynthesis. Once they've got that food in the form of glucose, that's then converted into energy for the plant through the process of respiration. And in that process, that releases CO2 back into the atmosphere. We therefore see the carbon being cycled between the atmosphere and the biomass quite rapidly, and it's not being stored in either for a long amount of time, and that's where we get those low residency times in terms of the atmosphere store of carbon and the land store of carbon. Carbon is also important for humans and animals. Carbon is basically part of a lot of what humans and animals would eat. It's in the form of carbohydrates, proteins and lipids are all carbon based. But not only that, they also make up, and I put it on fauna here, but it can apply for humans, carbon is the building blocks for life. So because carbon can form really stable bonds easily, it can basically create things very easily, and therefore it is the major kind of block used for pretty much all living organisms on Earth, and so it's really, really key for pretty much all life. We often hear that phrase, carbon-based life forms. That shows you how important carbon is for pretty much all life on Earth. Last thing is the fact is, in modern day, humans use fossil fuels, which are carbon-based, and resources to fuel economic activity. So coal, gas and oil are all good examples of carbon-based fossil fuels, but also key resources like wood and paper, which would come from trees, which are obviously created from carbon.